In this video, we're going to go over two additional variations for molarity problems. By the end of this video, you should be familiar with 1. How to calculate the amount of substance that is dissolved in a solution, and 2. How to calculate the amount of solution you need for particular experiments. Now, before we go over the new problems, I want to quickly recap the previous type, the problem where you're asked to calculate molarity. When we want to solve for molarity, we use the equation you see right there. Molarity equals moles of solute divided by liters of solution. To solve for molarity, you just need to have moles of solute, which we can get by converting grams to moles. Check. We also need liters of solution, which we can get straight from the problem itself. Check. The other type of problems are basically the same idea. We are going to be solving for something different. We should be able to answer questions that ask, number 1, how many grams of a substance is in a solution? For this, we basically need to solve for moles of solute first, and then we can convert it to grams later. And to solve for moles of solute, the problem is basically going to give us the concentration or molarity and the liters of solution. Number 2, we should be able to calculate liters of solution needed. Now, in this problem, we should be solving for this part of the equation. And that means the problem is going to tell us molarity and moles of solute. We need these two things in order to solve for liters of solution. And if the problem doesn't give us these two things, that means it would be impossible to calculate liters of solution. So basically, whatever the problem is asking you to solve, it should be able to give you the necessary things that would be able to solve the problem. Okay, let's go on to our examples. I'm just going to be going over 2 step-by-step examples for this video. And each of these examples are going to just be a little bit different. For this example, we're going to be solving for how many grams of NaCl are in 35 milliliters of a 1.5 molar solution of sodium chloride. Now, take a look at the left picture right there. We have about 35 milliliters of our salt solution, and the concentration is 1.5 molars. Now, if we know this information, we should be able to calculate exactly how many grams of salt is inside of that solution. So, first thing we need to write down is our equation for molarity. Molarity is equal to moles of our solute divided by liters of our solution. Now, according to this problem, we want to solve for grams, and it doesn't seem like there's grams in this equation. And that's because you actually have to calculate it after you have calculated moles of salt. So we actually want to solve for moles first. And if we want to solve for moles, that means we're going to need to know how much molarity the solution is and how many liters there is. And we will be able to figure those out because in this problem, it tells us that information. All right. Before we plug it in, I like to rearrange it first so that the unit that we're trying to solve for, which is moles in this case right now, is by itself. Right now, it's not by itself. We have to get rid of liters so that mole is by itself. To get rid of liters, we're going to have to multiply it on the right side. And if you multiply on the right side, you're going to have to do the same on the left side because this is an equality. On the left side, nothing cancels out, but on the right side, liters and liters cancels out. And what we're left with, if you canceled out the liters on the right side, you'll notice that moles is now by itself. Moles is equal to liters times molarity. So we're going to use this equation, and we're going to start plugging things in. So again, moles is equal to liters times molarity. How many liters is 35 milliliters? Well, I'm going to do the shortcut again. Put the decimal right there, right next to 35, and move it back 3 times. So it's going to be 0.035. So the amount of liters should be 0.035 liters. Okay? And we're going to multiply by molarity now. Molarity is 1.5 molar according to the problem. But if we write molar right now, it's going to be hard to figure out what cancels out. So I'm going to write down, instead of capital M, what capital M represents. Capital M represents moles per liter, right? Because molarity equals moles per liter. So now that you do that, you can easily identify what crosses out. Liters and liters crosses out, and we're left with moles. And that's what we were trying to solve for. So I'm going to write our equal sign right now, and if you type this in a calculator, 0.035 times 1.5, it's going to equal 0.0525 moles of salt. Okay, so we do have the amount of moles of salt. But the question wasn't asking for moles, was it? It was asking for grams of salt. But we needed to do this step because once we have our 0.0525 moles of salt, we can convert it to grams using the molar mass. So times and draw a line. The unit moles of NaCl goes on the bottom. The unit grams of NaCl goes on the top because that's what we're trying to convert to. You figure out the molar mass of NaCl by looking at the periodic table. If you add the molar mass of Na and Cl, you're going to get a molar mass of 58.44 grams for every 1 mole. So that means we put 58.44 next to grams, you put 1 next to moles. And the unit that crosses out now is moles of salt. So that means if we type this 0.0525 times 58.44, we're going to get our final answer. Okay, so if you type this in a calculator, we're going to get about 3.07 grams of salt. And that should be our answer right here. The question is asking how many grams of salt is in this solution. There's about 3 grams of salt in it. Now in this example, we have a bit of text right here. Your lab partner says you need exactly 0.095 moles of silver nitrate for your lab experiment. The silver nitrate is in a 0.2 molar solution bottle. It's not a powder. How many milliliters of silver nitrate do you need to pour out from the bottle? Okay, so let's try to make sense of this problem. Your partner wants a certain amount of moles of silver nitrate, but you don't weigh it out because it's not found in a powder, it's in a solution. So how much of that solution will you need to pour so that you get exactly 0.095 moles of silver nitrate? Okay, so we're trying to figure out how many milliliters of a solution we need to pretty much get that many moles of silver nitrate. So we're going to go ahead and write down our equation first. Molarity is equal to moles of our solute divided by liters of a solution. Now, what are we trying to figure out here? How many milliliters? So how many milliliters? Now, milliliters is not in the equation, but you can get milliliters if you solve for liters first. All right, so we're going to try to solve for liters. That means in order to solve for liters, we're going to need to have information about the molarity, the concentration of the solution, and also the moles of the solution. Okay, we could figure that out because we are given that information in the question. Now, before we start plugging it in, I'm going to try to rearrange it first because that's just how I like to do these problems. And in order to get liters by itself, we're going to have to do something to the equation. So to get liters by itself, I'm going to first multiply both sides by liters. It's kind of like what we did in the first example. On the right side, liters and liters cancels out. Now what this is going to give us is, let's see, do you see this? I'm going to write it the same way with the liters crossed out. Liters times molarity is equal to moles. Okay, you see how I got there? Liters is still not by itself, so I'm going to need to do something to this equation. To get liters by itself, I have to get rid of molarity. And we're going to get rid of molarity by dividing both sides by molarity. All right. On the left side, molarity cancels out. And do you see how it says now, with the molarities canceled out, liters is equal to moles divided by molarity. Okay, liters is now by itself. So this is the equation that we need. So we're going to use this equation and start plugging things in. Liters is equal to moles divided by molarity. How many moles is the problem trying to get us to get? It's 0.095 moles. Okay, and what is the molarity that the problem is giving us? The molarity is 0.2 molars. So that's what we're going to plug in. Okay, and just like before, it doesn't seem like you can cross anything out here. It's because we wrote molarity with a capital M. But how about we write molarity instead of a capital M, what the capital M represents? Molarity represents moles per liter. So I'm going to plug that right in there instead. And now the thing that looks like it will cancel out is moles and moles. So I'm going to cross those out. And what we're left with is liters on the very, very bottom. And since it's a fraction and it's a denominator on the bottom of like another fraction, it's going to actually become just liters by itself. So we know that this equation will solve for liters. We just need to type this in the calculator. So we start with 0.095 and divide it by 0.2. What we should get is 0.475, and the unit is liters. Now the problem is not asking for liters, it's asking for milliliters, but that's really simple. To get milliliters, if we have liters, we just take the decimal, you see the decimal right here, we move it to the right 3 times. Now we're moving it to the right 3 times because we're trying to get it to milliliters instead, okay? So the difference is which way you're trying to convert. So instead of 0.475 liters, we're going to write 475 milliliters. That should be our answer. So if your lab partner needs exactly 0.095 moles of silver nitrate, and we have a bottle that is 0.2 molars, we're going to need to pour out exactly 475 milliliters of that 0.2 molar silver nitrate. Okay, and that's how we do this problem. You might be wondering, what about the molar mass? Well, this problem, it doesn't require any conversions between moles and grams, so that's actually not even necessary for this problem. I have 2 practice problems here for you, and I want you to try these on your own. Now, I'm just going to let you know that each one of these you're solving for something different, so try to figure it out first. You will need the molar mass for one of these problems, so I'm just going to make it convenient for you, and I'll give you the molar mass right there. You're going to have to rewind. I didn't really think about this. And then I'm going to give you the molar mass of this one right here. Again, you're going to have to rewind if you want to figure out these molar masses, because I didn't quite think this through. Okay, so I want you to try these problems, and then in about 5 seconds, I'm going to put the work for it and the solution so you can see if you made the right steps. Alright, so for number 1, it should end up with 72 grams of sodium hydroxide. And for number 2, you should, since it didn't specify what the unit for the volume should be, you can either leave it as liters or you can change it to milliliters. It's 0.5 liters or 500 milliliters. And the work is right there, so if you didn't quite get the answers like I did, then you can take a look at my steps and see and compare it to your steps. All right. There's just a little bit more practice. I want you to go ahead and try those, and then I'll give you feedback.